We're talking about the distributive property, and by the end of the video, the goal is for you to not only be able to simplify each expression, but also understand with what each expression is asking and how the two are kind of related in the fact that we can use it to answer this same type of problem, but it's just from a different perspective. So let's say that we have two friends, and each of them are gonna spend the same amount. So let's say that they end up spending, they're gonna spend $7 on a ticket, and then they're gonna spend $3 on a candy bar, and they're gonna spend $5 for a thing of popcorn. And so right now I'm using simple numbers just so that we can see that, well, altogether we know that they spent a total of 15. So what this problem is really asking is what's two groups of 15? But we can still use the distributive property and kind of develop that concept of so that when we have harder problems, we can still use the same idea. And so what we can do is we can represent our two friends by using two groups, and in each group they're going to have they're each buying three things. So they're each going to spend $7 for tickets, and so we would have two groups of 7. And so by using the distributive property, we're going to see that, well, we would just multiply 2 and 7. Well, now we can see that each of them are going to spend $3 on a candy bar, and so now we would have two groups of 3 using the distributive property. You can see that, well, it's two groups of 3 is 6, and then last they're going to spend each $5 on popcorn. And so we would have again two groups of 5, and this is just kind of a strategy that you could use just so that when you're multiplying, you can see that you've multiplied all three terms. And so now, alright, for the tickets, they spent $14. For the candy, they spent 6, and then for the popcorn, they spent 10, and altogether they spent $30. And the same, just to kind of check our work, we know that two groups of 15 is 30. So now let's talk about what this really means. And so if we take a look at this problem and we compare it to its opposite. So now we have the opposite of two groups of 7 plus 3 plus 5. And so comparing the opposite, where this was a positive 30 for our answer, well, if we think about what's really happening in the story, these friends are spending money, and they're going to spend $30. And so I would ask my students, if they're spending $30, would we really represent that as a positive 30? And hopefully by now understanding integers and how we can use them to represent just our normal day, lives, we can see that this 30 positive, we wouldn't use that to represent of what they're spending. And we can ask and think to ourselves, well, what would represent getting $30? So in the story, what is actually receiving the $30? And hopefully, just by making sense of it, we can begin to see that, well, it's just about the perspective. And so who is actually receiving the $30 is the movie theater, is actually receiving the $30. And so now, just by understanding this concept, while yeah, we could say that they spent $30, we wouldn't use a positive 30 to represent that. And so now, thinking about just the opposite of of this movie theater earning the $30, now we can apply it to the two friends. Now if they are spending the $30. And so now we can take a look at it is now we can still model it the same thing, and just by thinking about this negative as the opposite. So where the movie theater was receiving the $30, now we see that the friends are going to spend the $30. And so now we can look at the model where here we're still going to end up with two groups or two friends, and we're each going to represent that they each bought three things each. So now there's the tickets. Here the 3 represents the candy bars, and now the 5 represents the popcorn. So now if we kind of compare the models, so this model, what we had, and now with this model, so right now they look the same. But now by thinking about the opposite, now that's where we can begin to make sense. And so what's really happening in the story problem? Are they each earning $7? So did this person earn the 7 and then this person earned 7 and together they earned $7? No, we can think about it as the opposite. What's the opposite of earning? Well, it'd be spending. And so what's the opposite of 7? Negative 7. And so now we can see that rather than having two groups of 7, we now have two groups of negative 7, meaning that they each spent $7. And then the same can apply for what they spent for the popcorn. So here, they each spent $3. Or I'm sorry, for the candy. They each spent $3 for the candy. And so here would represent that they each spent $3. And then the last is the opposite of earning $5 would be spending $5. And so the opposite of 5 is negative 5. And we can see, now we can represent that they each spent $5 for popcorn. And when we add these together, or actually after we multiply through, they spent $14 on the tickets, they spent $6 on the candy, and they spent $10 on the popcorn. And then they spent a total of $30. And the way that we just represent that is just by using a negative, which just means that they spent the $30 compared to the movie theater receiving the $30. So I know there's a lot of always confusion as why would we use negatives in math, and why would I do it that way if I can use it this way. In hopefully we can begin to understand that we can use this way, but it's really no different just by doing the opposite, just by actually understanding and what it is that we're solving. And so now we can come back to that first problem that I had, and now we can look and compare the perspective of each expression, where here this would be two groups of this quantity, and then this would be the opposite of the two groups of this quantity. And so if we still go back to that same concept that the two friends are going to the movie theater, well, this would represent the two friends, where now we don't know how much they spent for the tickets, but we can still represent that value. And then here, this 2C could represent that they each bought 2 candy bars, but we don't know how much each candy bar was. And then lastly, this could still represent the popcorn, where they each spent $4 on popcorn. And let's compare that to this scenario right here. Let's say we have our two groups, and going to be the same in each group, where we don't know how much each are spending for the ticket, and they each bought 2 candy bars, and they each spent $4 on popcorn. But now, if we take a look at where this this expression is 2 groups of the quantity T plus 2C plus 4, and this is just the opposite. And so if we think about it, if this is the opposite, then this would represent the movie theater perspective. And then since this is a negative or the opposite, that this would just represent the kids spending or the friends spending the money. And so now with using the distributive property, we would be able to see that we would have, well, we have 2 groups of T, 2T, plus we would have 2 groups of 2C, so we would have 4 groups of C, plus 2 groups of 4, which is 8. And so we could see that, well, they spent 2 tickets, they together bought 4 candy bars, but we don't know how much the candy bars are, and they spent $8 on the popcorn. Well, that's what the movie theater would receive. They would receive this amount. Well, now if we look at the opposite, well, what's the opposite of earning or receiving? What would be the spending, which is what the friends are doing. And so now we would look and see that, well, everything that we had for the movie theater perspective is just the opposite. And now we would end up with, well, now the friends are spending the same amount, but to represent it, we would use each term's opposite.